We're going to start our discussion on ionic bonding. So covalent bonding, as we said, was at the beginning of class, was nonmetals that are trying to fill their outer shells, and they will share electrons with other atoms, and it makes a very strong bond. Those electrons start going around both atoms. Ionic bondings, if covalent bondings are like this, where they're entwined, ionic bonds are more like this, right? They're held together, but they can be broken apart pretty easily, and we see that a lot of times in water. Adding salt to water, the two ions actually break apart and start floating around, and are also attracted to the water molecules. Because the thing is, these atoms in an ion are actually they're stable on their own, so they don't need another element or another atom to help them out anymore. So today we're going to start with talking about ions, and then tomorrow we're going to talk about how they bond. So from our reading, remind me, what is an ion?
Good question.
Let's get a good answer to go along. Yeah.
It's a positively charged. Yep. Atom.
There you are. Does it have to be positively charged to be an ion? Okay, so it could be positive or negative. It's just that these ions are just charged atoms. Why are they charged?
We're still charged now. Someone must have plugged it in.
What has happened to them to make them charged? No. They need electrons? That's not enough to make something charged, though. So when we started with the periodic table, let's take lithium as an example, upper left. Lithium has an atomic number of 3. How many protons does lithium have? 3. How many electrons does lithium usually have? Also 3. Well, if it's got 3 protons and 3 electrons, what charge is it? What charge is it? Yes, it's neutral. But now we're saying that these are charged atoms. An ion is a charged atom. So if lithium became an ion, what must change about it? What made it neutral? Sorry you have to sit through this. This is terrible. Yes. Okay, the fact that the electrons and protons are equal makes it neutral. So what makes something charged? It's lost or gains an electron or one or more electrons. So we're going to say they're charged atoms that have, and I'm just going to keep it general. So we'll say that have lost or gained, because it could be either one. Okay, so let's take these two possibilities. Let's say that something has lost electrons. If you take electrons away from something, what charge is left on that thing? Positive charge, because it's still got the protons to make it positive. It's just got fewer electrons. You probably haven't removed all of them, but if you lose electrons, you are positively charged. We will number that based on how many electrons it's lost. So it could be a 1 plus or a 2 plus or a 3 plus. Chemists always put the sign after the number. From our reading, which elements, big group of elements, is most likely to lose electrons? Right, so it talked about the first and second column and the third column, most of them. What do we call those collectively? Those are the metals. And in fact, these do as well. All of these metals in the middle tend to do that. We just aren't going to learn all of the rules for these, because these two, first two columns, third column, they behave really, really nicely and consistently. The ones in the middle are far more complex, and what we'll find is that these two and the third column, they almost always get the same charge every single time they ionize. The ones in the middle can have multiple states. So you'll encounter those if you go on in chemistry, but you won't really learn the rules for that until you get into second, third year of college chemistry. So, but you'll see them more often. But these are going to be metals. And we know the metals, they're all the ones on the left-hand side. If you think about this too, let's look at some of these that we were talking about. Let's look at lithium again. How many valence electrons does lithium have?
5.
Look at your periodic table. Yes, Ellen. 1. It's in the first column. So it's got one valence electron. That's one electron in its outer shell. Any inner shells that it has are already full. Just like we talked about with covalent bonds, these atoms want full shells. That's the most stable. So if it's got a full shell and then one in the outer shell, it's got to kind of say, well, I could either fill up my outer shell with a total of 8 electrons, so I'd have to find 7 electrons somewhere, or I could give up my 1 electron in the outer shell and become stable. It's a lot closer to go to 0 than it is to go to 8. So it gives it up. Next to it and below, magnesium. How many electrons are in magnesium's outer shell?
12.
2, right.
I'm looking at the wrong number.
Same question faces magnesium. I could gain 6 to fill up my outer shell, or I could lose 2 to expose the shell underneath, which is already full. Easier to expose 2, or to give up 2. So the metals are all going to lose electrons, and that will make them positive, but it will make sure that they have a full outer shell. Gaining electrons, if you get electrons, what charge do you become? Negative then. These are going to be the atoms that are closer to filling their outer shell than emptying it. Which category of atoms is that? Non-metals.
Yeah.
Now, does anyone see an issue with this? With these two categories? If we're closer to 0, we're going to go to 0. If we're closer to 8, we're going to go towards 8. What about if you're in the middle? Which elements are in the middle that are equally distant?
It should be all of them.
Carbon?
Carbon is. Why?
4.
Because it's got 4 in its outer shell. Silicon too. They don't usually form ions for that reason. It'd be too hard for them to either lose all 4 or gain 4 more. So they don't usually produce ions at all. Now when you get below into germanium, tin, lead, those are metals now. And they're going to follow some of the complex rules that I mentioned. And they are generally almost always going to lose some of their electrons because they're metals. But they could have a 1+, 2+, 3+, even 4+ charge. And sometimes some of these elements have multiple potential states that we won't worry about. But the metals are going to behave differently. For our first assignment, we're going to, part of it is just going to be write down the charge of these. So what you want to do is say, all right, I'm either going to go towards 0 or towards 8. How many electrons am I going to give up or am I going to get? So we had an example of lithium. Lithium had 1 valence electron. It would give that up to expose its shell underneath, so it would get a 1+ charge, and we would write it Li. We'd write it 1+, but on the computer we won't do anything up, so we would just put either Li 1+, or actually I don't know if you can do 1+, because chemists don't, so it would just be Li+. You might be able to, and you could certainly check. Magnesium, we said, that's in column 2. It would give up both of its electrons in that outer shell, get a charge of 2+, and that would be Mg 2+. And we don't do a plus. How about oxygen? How many electrons does oxygen have in its outer shell? 6.
6, yeah, right.
What's it going to do in order to have a full shell? Gain 2, which makes it what kind of charge if it gets 2 electrons?
Negative.
Negative, can you be more specific?
Negative.
2 negative. It's going to gain 2
Oh.
electrons, so it'd be 2-. We'd write it O, 2-. How about iodine? How many electrons does iodine have in its outer shell? 7.
7.
What's it going to do to try and fill it?
So -1. 2 minus 2.
1 minus. Sorry.
1-. It would try and gain an electron, becoming a 1-, and we'd write it I-. And again, these are technically all superscripts, so they'd be raised just when we type them in. We don't into the we can't do that. Second part of the homework is, what do we call them? When something becomes an ion, we actually name it differently so that we can say, okay, this is a sodium atom at its heart, but it's become an ion. So naming ions. If it's a metal, this is complicated. You write down its normal name. And then, after a space, write the word ion. So, for example, we had lithium. If lithium gets a 1+ charge, it becomes lithium ion. Magnesium becomes magnesium ion. Complicated, no?
No.
Non-metals are slightly more complicated, but you're familiar with the method already. They have their IDE version. And you know the rules for the IDE version already from our covalent bonding. So we had oxygen, N, and E. What does oxygen become with that IDE ending? Oxide. So we go to the second group, cross it off, it becomes oxide.
Oxide ion.
Just oxide is enough. It is okay to also say oxide ion. I'll have to double check with the homework to see if it would accept both. And then our other one was iodine becomes iodide. Yep. So for this first homework, it's a bunch of questions, again, 30 questions, but it's all of this sort. Either name it, so if it becomes an ion, what will its name be? If it becomes an ion, what will its charge be, which is just the numerical charge? And then finally, if it becomes an ion, what would its symbol be? And that I'll roll down in a second. That would be an I- or an O2- sort of thing. And we've still got about 10 minutes to work, so you can get a good start, see a mix of the questions, and ask any questions that you need to.